So continuing on to topic 4, input validation. Some of you have attempted to do this in the assignments that you've submitted, or have surely been curious about it, trying to control the input that the user's putting in, or help protect your program from stupid input. We can do what's called input validation to help us with that scenario. So Python has what's called try, except, else, finally, which is a group of statements that you can use together to help sanitize user input a little bit. And we'll use it in combination with loops next week. You'll see it can get even more powerful, but we're going to introduce it here so you can at least start using it. So here is using this group of tools. So first, I'm going to just create a pseudo input. Let's just pretend a user typed in the word word, and then it got assigned to this variable. The way this works is first, it's going to try to handle that input. And if everything goes fine, then it skips the except and goes to the else. And then it also does the finally. So the path can be, there's a couple of ways this can step through. It can either start with the try. So let's see what I'm trying to do in the tries. I'm trying to cast the input as an integer. If I use this input, it's obviously going to fail. So I'm going to just change this to a 5.5. We know this will pass. It will convert this 5.5 into a 5. There shouldn't be an error. So if I run this right now, you're going to see this print statement. First, it's going to try to convert it to an integer. It will succeed. And because it succeeds, meaning it did not have an exception, it will skip the except path and go to the else path. And it will print, hey, your input, pseudo input, which in this case is 5.5, will work fine. So it is showing that in this case, it runs the try, and then it runs the else. And then the finally will always run at the end, no matter whether the try was successful or not. The else and the finally in this case are not necessary. They are extra things that you can do if you want to utilize them. The try and except have to both be there, but the else and finally do not. But finally will always run at the end, and then I just put something in there so you can see the finally run. It says this program will now end. But if I change pseudo input now to, like I had originally, word, we know that when we try to cast word as an integer, it is going to give an error and an exception. And then what we will see is it will try that, fail, and then the except path will run, and it says the input whatever is not an integer. Actually, that's not the best way. It cannot be an integer. It cannot be converted to an integer, I guess would be a better way to type that. So it will try, it will fail, run the except path, and then it will run the finally path. So if I do this, you can see down here, the input word is not an integer, and this program will now end. So you just need to understand that the try will attempt to do whatever you're telling it to do under here. This can be multiple lines. It doesn't need to be a single line. I can do multiple statements here. If any of them raise an error, then it will go to the exception path. But if nothing goes wrong in the try loop or the try group, it will then go down to the else if you have an else and do whatever the else statement is telling you to do. And then it will go down to the finally path if you have a finally path. So that's really important. The way you typically see this used is it will try to get an input from the user, and then it will try to do something with it. So maybe the user was told to give you a float, and then it will check to see if the user gave you a float. And if it didn't, it will fail. It will raise an exception, and then the exception will tell the user, hey, you didn't give me the float that I asked you for, and then the user then gets the information they need to properly put in the input. And next week when we do loops, then we can just leave that within a loop until we finally get a good input from the user, and then the program continues. You won't have that ability this week because we don't have loops yet, but next week you'll see that that's really useful, because then you can guarantee by the time you get out of that try except within the loop, you know that the input you're getting from the user is what you expect it to be, because they got stuck over and over again, putting in input until they gave you what you expected. So it can be really useful and really powerful to make your program work better. So we'll be coming to that. You'll see that this week in this section, and then next week we'll be doing more try excepts within the loops. Because I have that new tool in my tool belt now, I'm going to do that guess a number game that I did earlier, but I'm going to make it a little bit smarter, because previously if somebody put in text, my program was going to fail. Like it didn't know what to do. It was just going to crash essentially. So now I have another tool that helps me force my user to give me good input. And again, I'm taking advantage of the while loop because I want to show you that I can make this program run regardless of how many times the user screws up. You won't have to do while loops this week because we're actually introducing that next week. But again, stepping through this program, I'm importing random, and then I'm creating that same variable I did earlier with a random number, and then the same as before, your guess equals 0. And now in that while loop, I'm going to do the well, your guess is not equal to my secret number, so it's going to keep doing this until the user guesses my number. I'm going to try to get input from my user. And so it's going to say, guess a whole number between 1 and 100. And it's going to take that input and try to cast it as an integer. And then it's going to, if that succeeds, is going to assign it to a variable called your guess. So if everything goes fine here, if the user gives me the number 7, for instance, the try will not have an exception, so everything will be fine. It will skip this part of the code and go down into the else path and do exactly what my program was doing before, where it's saying if it's smaller, say than my number, say my number is bigger. If it's bigger than my number, say my number is smaller. And then it will do that, whatever's in that section, and then it will go to the finally section. And I just stuck this in here because I wanted to show that finally section. It's going to say print. It's going to print and make another guess. Okay, so once you do that, if your number didn't equal my number, it's going to just run the while loop again. So it gets down past the finally section, and then it's going to start all over again and say, if your guess is not my secret number, give me another number, and then it's going to continue on and on. Maybe the second time the user said, no thanks or something for their input, that's going to raise an exception because that does not cast into an integer properly. So it will go down the except path and say, hey, that is not a whole number. And then it will skip the else path. So none of this will happen. And then it will say, make another guess, and then it'll start the loop over. So we can keep going around and around and around until we guess the number, and we can go around and around and around every time the user doesn't give us proper input. It just tells them, hey, you didn't give me good input, and then it starts the loop over again. So if I run this, I'm going to guess a whole number. I'm going to guess 55. And it's not going to show up on the screen, so I got to get out of here. Okay, so my number's smaller than that. 37. I typed it out, so it's a string, not a number, and that's not going to work in this case because you can't cast that as an integer. So when I run that, it's going to say, hey, that's not a whole number. Make another guess. And then, so I do 44. And it's, because of the way this works, it's going to continue going off the bottom of the screen. 33. Okay, negative 1,000. My number's bigger than that. I probably could have put some kind of a protection in to make sure the person couldn't put in a negative thing. We'll be doing more on that kind of stuff later. I don't know. Anyway, I can continue doing this until I get the correct number. So that's just, again, that's the same program I had earlier, but now we're being a little bit smarter about it. We're protecting against the user putting in text when I expect them to put in numbers. Okay, so some more unit testing tools. So we saw the assert almost equals stuff here earlier in this module. You can also do assert raises. This is a perfect time to put this in here because we can get type errors or value errors and things like that raised from user input. And we want to, if our program has a situation where that should happen, we want to make sure that that is in fact happening. So this test, assert raises, is essentially testing to make sure the program breaks when it's supposed to. And that can be pretty important because you need to know that if a certain thing happens, that your program is going to break in a known way so it doesn't continue through the program with whatever bad thing happened there, messing up other parts of the program. So here's just a very simple function. Checks an input, it takes an input, and attempts to return an integer of that input. So again, if somebody ran this function and input was a string, it's going to attempt to return the integer of that string, and it can't because you can't convert a string into an integer, and so it's gonna give an error. It's going to raise an exception. So that's all that function does. Either returns a number or raises an exception. And I want to test that. So I've got my unit test, import unit test as always, my class, my test case, I didn't bother changing the name of that. And then I've got test raises, and here's where I do the check for error. So I say with self.assert raises value error, because when I try to convert that to an integer, it's going to raise a value error. You can't just say, I want to assure that it raised an error. You have to say what type it is. There's type errors, value errors. Later on, we'll be creating custom exceptions, which will raise different kinds of errors. So you have to say what kind of error you're expecting it to raise. And it's saying the next thing that I do should result in a value error to pass this test, and I'm going to try to run my function and send it a string as a parameter, which we know will fail because we expect it to, and because it will fail, it will pass this test. So when I run this, I know it helps if I run the function first and run this. Yeah, hold on one moment. I did that incorrectly. I've gotten myself caught with a kernel issue, so I'm just going to restart. This will only take a moment. Okay, so I've got it running again. So this time I'm going to run my function before I attempt to run the test on my function. And then here I'm going to actually run my unit tests. So when I run this, you're going to see that it passes the test because this, when I try to use an input of a string, raised a value error. So that means it passed the test. Now, if I were to try to send it the number 4, we know that the number 4 can convert into an integer because it's already an integer. It will not raise an error, which means this test will fail. So when I run that, you can see that the value error was not raised as we expected to. So that's how you can utilize asserts to confirm that your program breaks when it's supposed to, which is kind of a weird thing to say, but it is something that you need to be able to check in certain scenarios. That's everything I have for this week. So as you get working on things, hopefully early in the week, if you run into issues, please let me know, or work with your fellow students, or put questions into the Q&A section in the module. Thanks.